And good morning or good afternoon, wherever you find yourself in the world. Welcome to today's webinar, Fast Tracking Your Path to Post-Quantum Cryptography. My name is Mitch Marchand. I'm a product marketing manager here at Keyfactor, and I have the privilege of being joined by Ted Shorter, the CTO of Keyfactor, and Vladimir Soukharev, the VP of Cryptographic Research and Development. Couldn't get a much longer title in there if we tried. He's from InfoSec Global, so I want to thank both of you. How are we doing this morning or this afternoon, Vladimir?
We're doing great, thank you.
All right. Well, just a few housekeeping items before we get started. First off, this webinar is being recorded, so if you do have to drop off, we've got you'll be able to jump right back into it. Over on the right-hand side, you'll see a little paper clip. That's where we've got some attachments. These are some amazing pieces that we've got for you to be able to download all around the post-quantum cryptography journey. And we'll follow up with a few more after the webinar as well. Please make sure to just have everything set on high quality. You're not going to want to miss any of the talk that we have here. We're going to do this in a format that is very informal. We're only going to have one slide to talk about real quick, and then we're going to just jump right into conversation. Also, please, we want to hear your questions. So over on the right-hand side, feel free to drop in your questions. I will be monitoring those live, and we'll bring those over to Vladimir and Ted as soon as we can, if we can work it into the conversation. If not, we'll tack them on at the very end. So with that, let's just go ahead and jump right into it. So the first thing that I want to talk about is there's a lot going on whenever we talk about PQC. We've done a number of webinars around this, and this is a slide that Ted had tossed over. And Ted, we've been working on this slide for who knows how long. But if we take a look at it today, how much has changed? And would you say that this is still on kind of that same track as we were whenever we first published this slide back in August?
Yeah, I mean, this is really, to some extent, also lessons learned from other cryptographic migrations, right? So you know, the algorithms age out, whether quantum computing has a potential threat to them or not. There's need for algorithmic changeover no matter what. And we've seen this same general, the process, and what really what we're talking about here is what has to happen in order, from the time that a standard actually gets created to the time that you can actually stop using the previous standards that those replace. The most recent one of those, or at least the most recent one that I think did cause a relatively significant sea change in cryptographic use, was moving from SHA-1 to SHA-2. That happened in kind of the 2010 kind of time frame. But basically, the standard gets adopted. That at that point, then people can implement those standards in cryptographic libraries, HSMs, that sort of thing. That allows them to be used in products. Once they're in products, then organizations, basically our customers, can start deploying them in their environments. But they can't really use them until they get to a certain level of critical mass. Because you don't want to turn on a new algorithm and certain things your environment don't understand, because you'll break stuff, right? So those are maybe somewhat to scale. Of course, you notice in this case there's no dates on those other than August. I think, just making a quick point, that from the time that SHA-1, basically the time that SHA-2 became a standard in replacement of SHA-1 to the time that on the right-hand side of the slide was actually about 14 years on average for most organizations. For this quantum transition away from RSA and ECC to the new NIST standards, we don't have that much time. Most folks are saying, that NIST is saying that RSA ECC deprecated by 2030. So it's a much more compressed timeline. But that said, it's I think, at least from what we've seen, we're still we're working with our HSM vendor partners. They should be coming out, most of them, I think, within the next quarter or so. We'll have official production HSM releases in basically in a quarter or two. But you're still probably looking at kind of that second timeline there is probably nearing the end of this year, right? So when you start looking at trying to be migrated completely by 2025, it's going to take some time.
Vladimir, anything to add?
Well, just a few points to bring up. Like the timeline is exactly from our experience how that should actually work. But we are realizing that this is, the biggest cryptographic change we're living through in history, right? So,
Yep.
and given the fact that it's the biggest one which we're yet to live through, we don't even understand fully how complicated it is. We understand that's the most complicated one. Now, how it's going to come from the practical side, from the engineering side, right? Because there's some problems where mathematicians are going to say, from a cryptographic point of view, you know what? I can solve this. This is easy. When you bring it to an engineer, it's not that easy. It takes time. It takes a lot of effort to work through. And another thing to understand is that this transition, it's not as optional as, let's say, the previous one. So let's say when we had a transition from RSA to ECC, right? If you have not migrated, you wouldn't lose much. Yes, your key size would be larger. Maybe your security will be slightly lower, but it's not going to be devastatingly, bad in terms of that it's not going to get broken. With PQC, if we don't migrate in time when CRQC is going to be available, that's it. Like all of the public key cryptography is just going to be devastated. It's going to be broken. So therefore, it's not an option not to migrate. Or if you don't migrate in time, the effects of that are going to be, quite huge and quite devastating to the industry and the government, of course, as well.
All right. That's a great start for us here. So let me, we'll get away from being, there we go, get away from the slides and let's just get into some conversation. So Vladimir, since you had already kicked us off, let's go ahead and jump into this. So last week we got some actually pretty big news that might have an impact on this timeline. So with the Majorana, what impact, if any, do you see that having on an organization's views of PQC and the transition towards it?
Okay, so when we talk about, quantum really has, three notions to it that are nearly independent, right? So we have quantum computing, quantum cryptography, and post-quantum cryptography. From quantum computing point of view, when quantum computer is being built, and there's a lot of great uses of quantum computing, right? But as a side effect, once they're large enough, they can break today's cryptography, and that's what we call CRQC, cryptographically relevant quantum computers. Now, there's quantum cryptography, which uses, principles of quantum mechanics to do like key establishment, etc., or do quantum random number generators. Has very niche use cases. And then there's post-quantum cryptography, which is cryptography that it runs classically, but it's immune to quantum attacks. So, and generally, the trend right now is to protect yourselves with post-quantum cryptography against the quantum computing. Now, we know commercially, again, it's hard to say what governments are developing, but commercially, IBM and Google were probably, the most heard of organizations that are building large enough quantum computers. They're scaling them. They're not just large enough to break cryptography, but it's just a matter of time to scale them. Now, Microsoft came up with this new technology which uses topology, and they are going to be able to fit more qubits onto a smaller device. And they're claiming that they're going to be more stable, etc., which means that the timeline of a CRQC is getting closer. The progress is there, and that means that the quantum threat is becoming more and more real, and it's becoming closer and closer to us.
Yeah, I was trying to read and understand all about it, but yeah, a little bit over my head. That's why we have you two here. So yeah, it's a very interesting point that, every time, and Ted and I have had this conversation as well, every time that there's an advancement made, this concept becomes closer and closer, and that timeline becomes much more real, and people are considering it more.
Well, I think that there is a lot of hype cycle around it too. So like with when Google had the Willow chip announcement, there was a lot of like oh, it's here already. It's like, no, not quite yet. But like every one of these announcements is just another step. At this point, almost all, and then this is different. I'd say 8 years ago, when I talked to cryptographic experts and so forth, maybe about half of them would thought it was only a matter of time before a quantum computer would be able to break RSA or ECC. Now it's probably more like 98 or 99%. It's effectively pretty much a certainty that it's just a matter of time. And now the only debate is how much time. Is it 4 years? Is it 5 years? Is it 10 years? I'm not hearing anything much longer than 10 years. And like I said, if SHA-1 to SHA-2 is any guide, took way longer than that. And that was a much, as Vladimir said, a much simpler transition than what we're talking about here. So there's a lot a lot of work ahead. I think it's also worth pointing out, and maybe this is where you were going to go next anyway, Mitch, was, I hope I didn't give the wrong impression on the first slide, right? To some extent, yes, we're waiting. If you're a large enterprise customer, you can't deploy these things in your environment yet because there isn't yet a version of Microsoft Windows that supports this stuff. There isn't yet a version of Apple iOS that supports this stuff yet, so forth. But that's all in the works, right? So, but that doesn't mean that you should just be waiting until that stuff comes out. And I think we should probably spend some time talking about the things that you can be doing. And that even goes into, I saw some of the questions that came in. There is some very nice, we have our wonderful partner in InfoSec Global here. There's a very nice Better Together partnership that we have around the impressive discovery capabilities that InfoSec Global has. As far as being able to find just a complete list of all algorithms, ciphers, keys, cryptographic libraries, all of that sort of thing, where they are, and then Keyfactor's ability to update, remediate, automate, and drive that transition, as well as being able to issue the certificates and roots of trust and so forth. So it's a good combination. But I think that's to me, when we talk about the things that you could be doing now, discovery is number one. Like, you can absolutely and should be doing that right now, right? That can lead to then planning and coming up with an idea. Once you know what you have, okay, how am I going to handle my transition? What do I need to do first? Building out automation so that even before you can deploy the algorithms, you can at least build out the ability to automate so that you can update everything, more or less with the push of a button when you need to, because by the time everybody's got support for that stuff, you're not going to have that much time. It needs to be automated. It cannot be manual. And I think those are just some of the things that you could be doing now.
Yeah, that was a perfect segue into the question that I was going to talk about is, knowing inventory is the first step. But Vladimir, I'll kick it over to you. As Keyfactor, we talk a lot about certificates and keys. That's our bread and butter. But what are some of the other cryptographic assets that people might not be immediately considering that they need to be inventorying and need to be ready to switch over to more of a PQC style algorithm?
Yeah, so there's actually quite a few of them. So again, as you mentioned, certificates and keys are obviously the first things that come to mind, but there are also cryptographic libraries, cryptographic algorithms, cipher suits, and key stores, right? So you really need to make sure that each one of them is still well managed, right? So let's say if you have an algorithm that is outdated, again, post-quantum transition, it's about changing your algorithms, but as a result, you need to change your keys, you need to change what algorithms your certificates support, etc. There's all this happening, and there's another side to keys, right? For example, if you want to achieve NIST level 5, right, you want to make sure that your AES key is the proper size, right? So you're using AES 256 in that case, or if you want to be compliant with CNSA 2.0 standard, which has specific regulations on what's the size of the hash function you're supposed to use, what's the AES parameters. So even the things that are staying there as algorithms, those still need to be managed. And again, of course, all the public key algorithms need to be looked into. And then if you go further, right, I mean, there's more things to that. Start looking at US versus the German standards. They're quite different. You want to make sure you're able to catch all of that into play, right? What are they using? What's different? What's the same, right? Like, for instance, if you're using elliptic curves, you're using NIST curves versus you're using German brainpool curves. You want to be able to catch all of this. So even if you're a US company, but you have some German cryptography in there, you want to catch foreign crypto to understand that, what, I need to update not only the one I'm compliant with, but any crypto I have in my ecosystem, because that could be a path into your ecosystem if you're supporting something else in there.
It's probably also worth pointing out, discovery, automation, all of these things are super important, even without a quantum threat of any kind, right? What we've seen in talking, again, through the partnership, when people do discovery, you might do discovery based on trying to find algorithms, with the idea of moving to quantum. It's very routine that people find that they're using algorithms that are already insecure today. So, just a general getting a better handle on your cryptographic hygiene is important, whether a quantum computer is threatening RSA or ECC or not. Same thing with automation. I think the other thing that's interesting, right? That timeline slide that we showed, you've got, and NIST saying things like 2030 to be off of RSA and ECC. You're going to have automation. You're going to have, very good control and oversight and automation around roots of trust as well. But it's a migration that you need to make, regardless. I think the other timeline that's following almost in the same time frame is the shortening of certificate lifespans, right? So there are proposals in the CAB forum right now. As many people know, we dropped it was like 3 years, then it was 2 years, now it's down to 13 months. There's a proposal in front of the CAB forum that has a phased approach that will take that down to 45 days. And that's right around the same time frame. I think they landed somewhere like 2027, 2028, where they've moved to that. I can't remember the exact timeline, but it's basically at the same point that most people are going to be trying to transition away from RSA and ECC. You're going to be also dealing with the progressively shorter public certificate lifespans. So I think that's, again, even more need for automation, more need for oversight, more need for discovery. It's all kind of come together in this perfect storm.
Yeah. To reinforce what Ted was saying in terms of, looking at your current vulnerabilities, right? I always make a joke about this. I say, you know what? If you find MD5, is it quantum safe or quantum vulnerable, right? And
Right.
People understand that the problem is much deeper. It's vulnerable today, and if you're using that, you have a problem. And unfortunately, there's still tons of MD5s, SHA-1s that are out there. And there's also another thing, right? If we, again, just look at it from today's perspective, what happens if you're a large US organization and all of a sudden you find Chinese ciphersuit in your ecosystem, which might cryptographically be secure, but it's out of compliance for you. So that's also a compliance aspect. You want to make sure you're using proper cryptography that is secure and that is compliant with your regulations.
I think that's a really good point on compliance as well, in that I think, we've already seen, like, PCI has updated, the newest PCI standard has something, a clause in there about having a complete inventory of algorithms and protocols used to protect your PCI payment card industry data. And I think that's one aspect of the compliance piece. I also think that typically, because we get asked, when should I transition? When is a cryptographically relevant quantum computer going to be affecting things? And what is Q day? All those sorts of things. I really do think that for most organizations, you're going to have to move, not because of a threat of a quantum computer, but it's the cause of the potential threat of a quantum computer is actually having on the compliance frameworks. So these frameworks typically follow the lead from standards bodies such as NIST and so forth. So when you have NIST saying 2030 deprecation, 2035 disallowed, when you have NSA, the CNSA guidelines to vendors basically saying, this is what NSA doesn't want to. What they basically have said now is, starting in 2025, right now, we don't want to buy any products unless they use quantum resistant signatures for firmware updates. Those are all sort of headed in that direction, but I think most people are going to need to move because there will very likely be some new version of PCI at some point in the future that is disallowing RSA and ECC, right? Same thing with ISO, same thing with other compliance frameworks in various industry verticals, and that will likely be the reason why people need to move. But that, to me, that's a good thing, right? It turns a nebulous, it's if Q day happened today, it would be absolutely catastrophic, right? But it's hard to plan for, how do you prioritize, a very catastrophic event that's sometime in the future when most organizations are trying to deal with, the fires of today, right? But compliance turns, sort of distant nebulous threats into business problems. that organizations do need to know how to prioritize and solve. And in that, to that extent, it's a good thing, right? It becomes something then, I need to do this because I need to be compliant. I don't have to have a debate on whether or when a quantum computer is going to happen or not. I need to do this or I'm going to get fined, right? Or dinged on an audit or whatever. And for most people, I think that will be the reason that they have to move. Point being, though, anything you can do up front now is going to save you time in the future. So start now.
Yeah, absolutely. And I want to take I'll call it a similar thread on the next question. But as we look at all the different changes that are happening, we also have TLS 1.3 and all the different versions and everything coming along. What are the implications of that and the requirements that are associated with it? And how does that tie in with the post-quantum journey?
Yep, I'm happy to answer that, or you can, Vladimir. I've been doing a lot of talking, but maybe I'll start and you can jump in. But I think TLS 1.3. So IETF has basically said they're not going to update TLS 1.2 with the new quantum resistant algorithms. So if you want to use post quantum, it's going to have to be 1.3. The other thing that's worth noting, there's a lot of the threat that we're actually under right now, even before Q Day, is this idea of capture now, decrypt later. So I've talked to a lot of banks, financial institutions. They tend to be kind of those in government are kind of leading the wave of the early adopters of trying to move to quantum resistance. A lot of them have told me they're starting with TLS 1.3 on the perimeter. If you get TLS 1.3 on the perimeter, there's a couple things that happen. First of all, right now it doesn't help you, but TLS 1.3 is going to get updated for those standards. When you start getting new implementations of those, the other thing that's really cool about TLS 1.3 is the first TLS version where they use two different algorithms. There's one with the certificate that's used to authenticate the website to the browser, and then there's another one that's actually used to exchange the key that encrypts the tunnel between your browser and whatever website you're visiting. When TLS 1.3 gets updated, it'll basically switch to using ML-Chem, which is one of the quantum resistant standards for that tunnel. So it basically becomes a way, if you move to TLS 1.3 now, as those TLS 1.3 implementations get updated, you'll be able to effectively become quantum resistant as soon as you have things on the other end that are able to do that. So that is something that it's a step you can take now that is probably the fastest path to the biggest threat of protecting capture now, decrypt later, right? It's much easier to capture stuff on the open internet. So even if it's just your perimeter, that's a good place to start.
Yeah, I completely agree with the fact that protecting the perimeter is probably the first step, because internally there's less attack surface. I mean, it exists, but there's less attack surface.
There's certainly insider threats. Yeah, the idea that for sure we haven't solved that yet either. But
but for the perimeter, of course, there's way more possible attacks, etc. And it's important to inventory, right? So when you're migrating, again, first thing, of course, getting to TLS 1.3 is essential in this step, right? So if you're below that, then there's a lot more to do. But once you're in TLS 1.3 and you start doing the PQC upgrades, right? You want to make sure you know exactly which cipher combinations you're supporting. You want to make sure you're not allowing, the weaker cipher suits that are quantum vulnerable for your essential, outgoing connections. So you want to be sure, again, going back to inventory, you want to inventorize that each of my endpoints supports these cipher suits, and I want to make sure that among them, I am supporting the one that's going to have ML-Chem in them. And I want to make sure that I'm not allowing anything that is weak in there, etc. Because again, even if we talk about TLS in general, right, there's lots of cipher suits. Like TLS 1.2 in general, that's allowed today, but not every cipher suit combination is actually strong enough. There's some weak ones that should be disallowed. Right. Unfortunately, that's not always the case. Organization would say, you know what, I got TLS 1.2, I'm good to go. I feel that I'm safe. No. Right. Look at all the cipher suit combinations you're supporting and clean out the weak ones out of there. Yeah. 1.3 is nicer in terms of that. They have much smaller set of these cipher suit combinations, makes it more manageable, and it's easier to migrate. But again, it's given the fact that we're going to have classical ones and post-quantum ones, that's going to actually essentially require deeper view on this, and it's continuous view, right? Because nobody knows how it was upgraded. What happens is that a lot of times IT engineers or whoever takes care of that, they're not cryptographers. They might not even understand the difference between the supported algorithms in there. So that's why it's important to have a view of this, and having somebody who is cryptographically keen, understanding that this is compliant with respect to my organization's policies and the security levels needed.
Yep. And you touched on something there too, I think, Vladimir, that, inventory isn't just something you do at once at the beginning and then start the process to migrate, right? Because things change, right? People will misconfigure things, new machines show up, IT environments are far from static, and it's something you need to keep doing on an ongoing basis, or else you're going to still wind up in trouble.
Yeah, and as we talk about these dates continuing to move closer, again, inventory, number one, but are there other things that we can be doing in parallel? Like we've already talked about TLS, and we need to make sure that our architecture and infrastructure is all there. I guess I'll kind of merge a couple questions and say, what else can we be doing at the same time? And what are some of the challenges that we're already seeing come up with those that are at the forefront? Are there any hurdles that we didn't see coming? Because we always know with something like this, it's great to have a plan, but as soon as you start implementing a plan in the real world, that's when, oh, we didn't think of that, or that came up. So kind of a two-pronged question of what can they be doing now as well as inventorying, and what have we seen are other challenges? So Vladimir, I'll start with you.
So again, as we already mentioned, inventory is essential to do, but we realize that our end goal is to be quantum safe. Now, PQC algorithms are very different from our commonly used RSA and ECC algorithms. Even the flow of the encryption schemes, for instance, for ECDH, we're using a key agreement, while for a similar analogous component in PQC, we're using KEMS. That's a slightly different flow, right? From a mathematical point of view, it doesn't really matter, if you can actually show that the securities are quite equivalent, etc. But from engineering point of view, these little things, which might seem little, are not that little. Again, you have to test it out. You got to take maybe a few applications, start migrating, start seeing the implications. So really start testing this out. And another thing, nobody says that we're done with the PQC algorithms in terms of which ones are going to get standardized, right? So we have a first set that has been standardized. There's going to be more coming, which means that the changes, even after the PQC migration, you're going to be doing more changes and more changes. So it's good to start preparing your environment to be crypto agile. You want to make sure you're able to adapt to changes. You might even have some parameter changes among the standardized schemes, or maybe there's going to be some tweaks coming along the way, because the PQC schemes are still, considerably fresher than ECC and RSA. So therefore, tweaks might be coming. More algorithms will be standardized. If you notice, NIST still is finishing round 4 standards, so we're probably going to get 1 or 2 algorithms out of there. NIST has a parallel track to standardize more digital signatures. That means these changes will be coming in years over years over years. It's probably the first time in history also that we're seeing that we have a cryptographic standard which is evolving as the time goes. So agility, testing out agility, starting to bring it in, especially if you're doing new applications, because it's easier to implement agility in those ones. Start adopting the concept of agility and testing it out.
Yeah, I agree. I mean, we already talked about inventory, planning, building out automation. Testing is absolutely important. There is, if you want to play around, we have PQC labs. We're at a point now where our current releases of Bouncy Castle, EGBCA, Command, Sign Server do have support for some of these algorithms already. So you can play, even though if you don't have anything in your environment that can understand those algorithms, you can at least make sure you can issue certs with the right formats, all that kind of stuff. Like you can do all of that now. The other one I guess I'd mention is talk to vendors, right? Because going back to that first slide, you can't, like I said, you don't have a version of Windows or anything else in your environment that supports this stuff, but you can start talking to your vendors and asking them questions on like, what is your quantum roadmap, for your critical vendors that are providing infrastructure. Really anything that has a web interface is going to have to get updated. And so like, what is their timeline on getting that stuff updated for support for these new algorithms? Because you can't move until they do. And so I think that's something you can also start doing. Some of the vendors have actually, I'll pat AWS on the back, even though they probably don't need it, but they've been very good about publishing. It was in a blog, but basically, here's our plan for how we're going to handle a quantum transition. They even talked about TLS 1.3. They talked, so they have this kind of plan that they laid out. Be asking your vendors, both on security vendors like Keyfactor or InfoSec Global, but also other vendors, like Microsoft Azure and your network equipment vendors, your hardware vendors, your software vendors, everybody. I think you should be asking them. Quick plug. Next week is Tech Days. That's the Keyfactor user and partner conference. I'm actually chairing a panel with InfoSec Global, IBM, Thales, and Keyfactor. It's called "It Takes a Village," and it's actually it's going to be diving more into this kind of, this really is an ecosystem, and we all kind of have to move together. So I think those are all things you could be doing now. I guess I also just want to, there's something that Vladimir said on the agility piece. It's kind of a soapbox, but you also mentioned, we still see people using SHA-1, needing SHA-1, begging us to run SHA-1 PKI for them at times. If you're designing a new system today, but an IoT device or an in-house system or really anything, if you expect it to be around for more than 3 years, please design in updatability, right? So a firmware update, some way to update roots of trust and cryptography and so forth. What we've seen, I think, especially with IoT devices and that sort of thing, it's harder to make them updatable. It's harder to update them, right? But that doesn't absolve you from the fact that you're going to need to or want to change out the cryptography. We've seen people get burned by this with still needing SHA-1 or MD5 or things that are already outdated. If you're designing anything new, please figure out some way to have it updatable. Even if at least don't be surprised by the fact that you're going to have to do that again if it's going to be out in the field and use for more than 3 years.
All right. So that, again, great segue, Ted, talking about it takes a village. I've actually asked Joanna to toss in. We did another PQC series where one of the titles was "It Takes a Village," because I think you're absolutely right. Making sure that the vendors are on track is a huge piece that probably not everybody's thinking about. And so let's jump right into Vladimir, what was it about Keyfactor that we saw this partnership start to bloom and the unique value proposition that bringing our two companies together has really shown?
Well, first of all, I think it's comprehensive discovery and then actionable items off of that. So we're trying to get a full cycle of how you can manage things, right? So, for example, Keyfactor Command coming together was AgileSec Analytics. We can have a very comprehensive discovery of everything that we find inside the environment. And then keys and certificates can be managed by Keyfactor, so we can automate this whole process, because you wouldn't want to do it, one phase at a time, but we want to make sure that we're able to not only say, here, we found it, and then, okay, what's next? What do I do about it, right? We want to make it actionable, and that needs to work, because usually, the more it is kind of automated and out of the box, the easier it is to run for the customers, the easier it is to get it, to get it adapted. So coming together, we can really have more complete cycles of, going through the cryptographic environments and updating and fixing it where needed, depending on what the use case is, right? Maybe we found an outdated certificate, maybe the keys are too small, maybe the algorithm is improper. There's tons of reasons why changes might be happening. Again, not even talking about the quantum threat. Quantum threat, I think we're fairly clear on this, but there's a lot happening. And no, just one little, aside. The whole quantum threat really is starting to raise a lot of long time overdue issues, which we're trying to resolve. And I'm really thankful to the quantum threat saying, okay, great. It would have been great to do this stuff 10 years ago, 15 years ago, but finally we're doing this. Finally, we're coming together, and finally we're combining our solutions to make the cryptographic world a better place in this sense.
Yeah, it is cool. I mean, we've done interop testing, with folks that we, technically compete with, at times, right? Because it's, as citizens of the internet, it's important that all this stuff works together, so that I think that's an important piece. I will say that just one question that came in. There were two questions actually on performance and that sort of thing. One was about classical computers handling post-quantum. One thing, the post-quantum cryptography is about algorithms you can run on a conventional computer that are resistant to quantum computing. So by design, actually, quantum computers will be terrible at the new PQC algorithms because they're designed to be extremely hard for quantum computers to handle. But there is a question of like, okay, how do these algorithms compare performance-wise to to RSA and ECC? Certainly be interested in your opinion on that, Vladimir. I think I would say from our testing, I would say, it's maybe in some cases percentage points worse, 5%, 10% more compute. In some cases less, because some of these are actually, because like the hash functions like SHA-2 and SHA-3 are largely unaffected by quantum computers. Some of these new algorithms are actually kind of hash based, and hashing is pretty fast. So in some cases, the speed, it really looks like the speed isn't going to be that much of a problem. The compute isn't going to be the problem. The bigger problem is likely going to be the keys are bigger, the signatures are bigger, it's databases, it's bandwidth, it's that kind of stuff. But I'm curious to your opinion on that too, Vladimir.
Yeah. So, well, in general, if we talk about, CAMs or digital signatures coming from PQC world, they are in general slower. But the thing is, just to understand the impact, right? How does the connection usually happen? You would run a public key algorithm to establish a key once, and then you're using your good old AES to continue on with the rest of it, right? Once you need to reestablish the session, yes, you would run it again. So the percentage, although let's say if it's 50% slower, but you're running it once every that amount of time, and then everything else is encrypted using AES. So the effect is really minimal. Yeah. So when we talk about percentages, it's there, but it's minimal. Similar on the digital signatures, right? So and that's one interesting thing also when we talk about PQC. The algorithms, some have larger key sizes, some are smaller, some are both, right? And sometimes you have to make choices, and that's when coming back with your agile approach for supporting multiple algorithms at the same time. You want to say, you know what, for these cases, I really care about the speed, and for other cases, I care about the bandwidth that I'm getting from the keys. Yep. And of course, you would have to look at these kind of things. Of course, there's things like, again, key size is probably the biggest obstacle that we're seeing, because let's say if you're sending a packet and then you're not used to being so big, right? Mm-hmm. That's why, we're looking at different options, and we have to support multiple options for each use case, and to make it, less, to make our environment kind of, I say not to make it even, to keep our environment to be as usable as it is today. Yes, there's impacts, but majority of obstacles have been either taken care of, or shouldn't be too hard to take care of those obstacles.
Yep, that makes sense.
Awesome. Well, I think that covers the big questions that I had. Now, we have had some come in. This first one I would say is a little bit of a loaded question, so I'll just preface it with that. What are things we consider in a CBOM? And then a follow-up to that is, can InfoSec and Keyfactor scan all those components and attributes? Because I know, Ted, in all of my conversations with everybody internally, the word CBOM is continuing to come up and come up and come up, as is SBOM. So if one of you could take on just kind of basically what is a CBOM for the lay people like me, and then what are the things that you would consider into it?
That sounds like a Vladimir question, but I'm happy to answer it as well. The answer to the second part is yes. We can scan everything, but yeah, go ahead, Vladimir.
Yeah, to explain what a CBOM is, right? So we kept on saying word crypto inventory and CBOM, and I really want to distinguish between the two, right? They're quite different. Think of CBOM as when you're buying a package of some food, right? You have a list of ingredients. That's basically what CBOM is. So you're provided with some software program or hardware, and you're going to have a list of ingredients in there. What in terms of cryptography, of course, right? So we know what the SBOM is. CBOM is sort of the extension of CBOM. Now, when we talk about cryptographic inventory, the difference is that that's much deeper. That's actually checking what's inside or what's scanning there. So from a cryptographic inventory, you can always extract a CBOM. Think of, you take your inventory, you filter it out, you get CBOM out of this, and you put the label on the machine. Now, somebody can check it by running a crypto inventory tool to make sure that it actually matches, but that's a different story, right? So technically, what ISG and Keyfactor cover is way beyond what's needed for CBOM. So CBOM is sort of, how in mathematical theorems, you have a theorem, you have a corollary, right? So a theorem, we solve the theorem, and the corollary is sort of this effect, you automatically get this little thing out of it. So that, in that case, once you have your full inventory, CBOM is there automatically.
Okay, awesome. A couple that are kind of tied together is how close are we to changing the crypto algorithms when we change the certificate? I'm not sure I fully understand.
Yeah, I wasn't quite sure. I saw that one as well. I wasn't quite sure I followed it. I think what they're saying, I mean, you don't want to deploy a cert before your systems can, if you don't want to deploy a certificate that's signed with MLDSA until you have systems in your environment that understand MLDSA. Otherwise, you'll just break stuff, right? So I guess that's the question of, typically what happens is, and it goes back to that timeline slide, right? That there'll be some release of products and operating systems and phone OSs and everything else that contains, among other things, support for the new algorithms, right? Even if you're not using those algorithms, you have support for them. That's one of the things that ISG can help with as well, is just here's a crypto library, here's the version of that crypto library, here's the algorithms that are in it, here's the ones that support post-quantum, here's the ones that don't, so you get an idea of where you're at as far as that sort of thing goes. And then at some point you make the decision, like, okay, now I'm ready, I have enough support, I am going to roll out a new quantum resistant root of trust, new certificates, that sort of thing. And you can do so with confidence because you know that the systems that you have underneath have support for those algorithms, and you're not going to break stuff. So it's, you need the implementation support in your environment before you can actually deploy the certificate and so forth with new cryptography, with one exception, and that is there is work coming out of the X9 standards group. That's a financial body that actually is working on standardizing basically a regular X509 certificate signed by RSA or ECC with a signature with a quantum resistant algorithm in a non-critical extension of that certificate. So basically, if I can deploy that today, and anything that sees it will just look at it as a regular RSA or ECC certificate with an extension in it that it doesn't understand. But then if you, as you roll out systems that support that, then they'll have to start using that signature as well, validate both signatures. So that becomes a way that you could, in theory, not have to wait until everything in your environment is updated before you can start deploying quantum resistant algorithms. You could basically start when anything in your environment is able to handle quantum resistant algorithms. So that could speed up that piece. And that's actually, so that was Stuart's question I just saw come in, was about hybrid certificate and so forth. What I will say, and this is also something, we have not been in a long time in PKI or cryptography operating so close to the bleeding edge of the standardization process as we are now. So, a lot of us are used to having, PKI was, like there were cases in the early 2000s, where like, hey, the certificate works with, Netscape, but it doesn't work with Internet Explorer and that kind of stuff. Like all that stuff got ironed out, long before most people that are in the IT workforce today entered the IT workforce. But that stuff happened. We're entering that phase again because there's so much new implementation happening so close to the standards. What I would say when we talk about hybrid, I mentioned the X9 standard for hybrid, this kind of dual signed certificate that basically will be accepted by one of today's machines just as a regular RSA or ECC cert. That's the hybrid one that, at least personally, I think I'm the most excited about because of that idea that you can move. I can start deploying quantum resistant stuff in my environment before, because with SHA-1 to SHA-2, you had to wait until everything in your environment understood SHA-2, right? And so, which is why it took 14 years, because you got to update everything in your environment. This idea of a hybrid certificate moves that forward. What I will say though is hybrid, the word hybrid is getting used for other things as well that don't have those properties. So there's hybrid keys where you're basically it's a signature with both an RSA or ECC algorithm and a quantum resistant algorithm at the same time. So it's basically like two keys combined together. That gives you a benefit of, if I'm going to break that, I have to be able to break both RSA and MLDSA. So it kind of hedges the bets on like it's new cryptography and it's quantum, like all that kind of stuff. But that doesn't give you that same property of you can only deploy that for things that understand that specific hybrid standard. So like we're just in a point right now where there's just you have to be sure when you hear words like hybrid and so forth that you're actually referring to the same thing, or you can wind up with kind of a metric imperial sort of standards thing and wind up with things that don't work together.
Yeah. All right. Well, we are over time already. So again, I just want to thank Vladimir and Ted. This has been a great conversation. Thank you to everybody that put in questions. Joanna, our field marketer, has put in a few announcements. So to check out the PQC lab as well as our other PQC series. And again, Vladimir, Ted, thank you so much. Looking forward to seeing you guys in Miami next week and continuing on our PQC journey. Thank you all.
Good. Yep. Thank you.
Thank you.